Hi folks, it's Ron with Ideal Industries. Hey, welcome back to the channel, and I'd like to introduce you to a new line of advanced wire map testers from Ideal Industries. And if you'd like to learn more about the new VDV line of wire map testers from Ideal, contact our customer service department and we'll find a way of getting one of these in your hands. Now, the VDV testers and line of testers, it stands for voice, data, video, by the way, if you don't know that. And there are actually three new testers in the line, and one is the VDV, which are standard basic model. Then we have the VDV Plus, which has some additional features to it. And what I'm holding here is the VDV Pro. Now, the VDV Pro has some additional added features you're not going to find in traditional wire map testers for this kind of a price. And that's the fact that it can actually work on an energized circuit. And so, say, for instance, you're out at an IP camera someplace and you plug the cable that feeds the camera to the top of the tester. If it sees PoE voltages, it's going to indicate that, and it's going to indicate the polarity and the pins and what the voltage actually is. And it also will identify, hey, am I on a gigabit Ethernet switch or 100 megabit switch, full duplex, half duplex. It'll, again, identify those things. And if you work with phone circuits, it'll identify ISDN lines and traditional PBX lines, too, as well. So, again, the VDV Pro has some additional features you're not going to find on traditional wire mappers. So let's take a look at the VDV Pro, and I'll show you how to use it. Here's a close-up of the VDV Pro in its box, and along with all the identifiers and remotes you can order separately for it. And the remotes and identifiers are all a la carte. You can order them separately. Now, the tester always comes with one remote for testing coax, phone, or data cabling. But here are 12 extra data remotes, and they're very handy, and they're labeled 1 through 12. And it is a very labor savings type of thing because you can put the different remotes into different outlets in different parts of the room or the building. Go back to where the panel is and actually test each of those cables separately and identify that you have, say, the 10th remote on the end of the cable. And again, we can not only identify, but we can test the cabling here as well. There's also 12 coaxial remotes, which are very handy when we're testing and tracing coaxial cables. And you can also order 24 identifiers. And the identifiers are used for identifying circuits and basically just tells you it sees the 12th identifier on the end of a cable. But all of those are very handy to have if you're out there tracing and testing cables in a building. And again, you can order those separately, and all those remotes will fit in the main case that comes with the main unit here. Now, here's the main box that the VDV Pro is going to come in. And it comes in a very nice box, and we've opened up the box and take a look at what's inside of here. We can see that the tester comes in a nice zippered compartment here. And one of the most important things I guess I'll show you is right here on the back of that zippered compartment are the instructions for your VDV Pro. So you might want to read those when you get a chance and make sure you understand how to use all the different features of the VDV Pro. Now, if we open up the zippered compartment here and take a look at what we got inside the case, what we find inside of here, first thing is a laminated card, which has got the wire color code configurations on it, which are handy to have if you can't remember the particular configuration you're working with. The main unit sits right here in this compartment and can be pulled out. In that main unit, has got a remote that popped out the bottom of it for tracing and testing of coax, phone, and data cabling. Okay, I'll show you a little bit how to use that. Now, there is also a zippered compartment over here, and in this zippered compartment, we've gone ahead and thrown in all the different adapters you might need, whether you're working with phone, coax, or data cabling, and whether you're working with a jack, a plug, or just a bare conductors on the end of a cable. Okay. We also have thrown in several adapters here, and the adapters are for coaxial cables. So if you're adapting from F to BNC or F to RCA or something like that, you'll have an adapter that allows you to still be able to test that cable. Now, since the tester does have a tone generator built in it for tracing of cables, you might want to purchase a amplifier probe for actually picking up that sound that the tracer is going to put out. And so we've added a pocket over here for that as well for you. And, of course, over here on the other side are little pockets that we could put all the different identifiers and remotes that I showed you a minute ago. And if you've gone ahead and ordered the case and added a probe and those remotes and identifiers, you're going to have a kit that's going to allow you to test basic coax, phone, and data cabling, and going to give you everything you need in this nice one little kit. So let's take a look at some of the features of the VDV Pro, and I'll show you how to actually use it. Here you can get a good look of the VDV Pro tester here, and one of the first things I'll show you on the tester is we can look at the top of the tester and see the different ports the tester has. It has a phone port for obviously doing phone testing, a coaxial port for doing obviously coaxial testing, and that's an F connector, but you can change that out using those adapters to either BNC or an RCA if that's what you're dealing with on your coax. And then a data port over here. Now, you notice on the data port there's metal around it, indicating that we can work with either a shielded or an unshielded category cable and actually test the shields as well. On the back of the tester is where the battery is stored, and with one screw I can pull out the 9-volt battery that's in that. And I think the specs on the tester say that the tester will work for 20 hours of continuous operation without the backlight. But with the backlight on, how long those batteries are going to last really is going to depend on how long you leave on the backlight. So always make sure you have a good fresh battery, 9-volt alkaline. And the tester has a display on the front will let you know when that battery life is getting too low, okay? Now, the remotes are stored in the bottom of the tester like that. And the remote has similar connections like you see on the top of the tester. It has a phone port. It has a data port for doing the data testing. And the coaxial remotes store in that remote and can be plugged into a coaxial outlet. Now, the coaxial remotes can be stored on either this side or the opposite side of this remote. Either side doesn't matter. And when you pop that in, it can be popped in on either side. Wouldn't really matter. It'll store inside the tester. And again, extra remotes is always a pretty good idea, and we'll talk about that as we get into the testing here. And if I'm going to go ahead and turn the tester on, I turn it on, and the tester will automatically turn back on in the last mode that it was in when it was turned off. In this case, that's indicated here at the top of the display, indicating it's in the phone setting here, okay? And we've got a backlight on the tester, and you just noticed it turned off on us there. And we could just the amount of time, again, that backlight stays on. But again, we're in the phone testing mode. And so the tester's showing me 0 feet because there's nothing plugged into the tester. And it shows me 2 rows of numbers. The top row is what it's supposed to be. The bottom row is what it actually is. And again, it's showing a bunch of opens there. Now, the 3 basic modes are phone testing, coax testing as well. And we know we now are in the coax setting, so I hit the coax button mode. And we're testing and looking for the shield and the center conductor and a piece of coax. And again, nothing out there. And if I push this button over here, that's the data mode. And it's now showing me on the top of the tester, we're in the data mode. And it's looking for data cabling and obviously looking for 8 wires in a category cabling. And the bottom row shows all opens. So again, there's nothing plugged into the tester. But I can go back over to the phone tester setting by going back over to phone. Now, another key little button you find on the tester is this one. It's the little music symbol you see, and that's indicating the tone mode. And so the tester has a tone generator built into it used for tracing of cables, and we'll talk a little bit more about that, but I can turn that on. When I turn it on, it shows me I'm on the tone mode. It's on the 3rd type of the digital tone that can be generated, and there's several tones that can be generated, and we'll talk about that as we get into it. But I can turn that right back off, and by holding that button down, and it turns off the tone mode again. Now, another button you'll find on the front of the tester you got to know how to use is this wrench one, which is our tools, is what it's indicating. So if I push that once, it's going to now ask me something, and what it's asking me is it's showing me the 0 feet here, and it's showing a percentage. And the tester has a time domain reflectometer built into the tester, which is used for measuring length in cables, and can be done very accurately. Now, you have to know what's called the nominal velocity of propagation of the individual cable you're testing the length on, though, because it can vary between coax and data networking cables, and you can really put measure length on any type of cable, even Romex, but they all would have a particular nominal velocity of propagation. Now, I could change this number by these function keys here, either up or down, and actually change that setting. And for data networking cables, 72 is a pretty common number, but it can vary quite widely between coax and stuff. So we'll talk more about how to set that when we get into using the TDR. Now, if I push this button again, it's going to ask me, okay, it's showing me an icon here, which is showing me a backlight is what that's indicating. So it's indicating, okay, how long is the backlight going to stay on it, and it's checked that it's on. And it's now set for 10 seconds. And again, by using these function keys, I can change that to 30 seconds, 60 seconds, up to 300 seconds, which is about 5 minutes, or no backlight. And as far as battery life is concerned, no backlight is going to make those batteries last longer. In this case, I'll set it for 10 seconds, okay? And if I hit that function key one more time, it's now going to ask me, do I want the readings and measurements to be read in length in feet or in meters? And so I can set the tester for either one. In this case, I'm going to set it for feet because I'm standing here in the good old United States. All right, and if I hit that one more time, it goes back into the function mode, and it's saying, okay, I'm ready to do phone testing. So next, let's actually show you how to make some of those tests using this the VDV Pro. and we'll show you what the meter actually can do for you. To use the VDV Pro for data testing, I'm very simply going to turn the tester on. Now, it's automatically in the data mode, so I don't have to worry about pushing the data button to set it for that, because I know the icon is already lit up there, so I know it's ready for data. Now, tester's telling us a couple things. One is it's seeing no feet, so it doesn't see any length of cable. And it shows 2 rows of numbers, and the top row is what it's supposed to be. The bottom row is what it actually is. And since nothing is plugged in the top of the tester, we obviously don't have anything plugged in, so it's not showing us anything. So I'm going to go ahead and plug a known length of cable or patch cord into the top end of the tester here. And now the tester shows me a little bit more. It shows me it sees a cable. It's about 5.5 foot in length, and it shows 2 rows of numbers again. And since the bottom row numbers, nothing's lit up again because there's a complete open on the other end of this cable, we have nothing to test. But let's go ahead and plug the remote that comes with the tester into the other end of the cable. Now the tester tells me a lot more, and it still says it sees about a 5.5 foot piece of cable, but it actually sees the first remote that comes with the tester. And that little icon right there is the icon for a remote. So it sees a remote, not an identifier. Now, it gives me a check mark on the top of the meter here, and that indicates the cable's good. And we know that because when we look at both rows of these numbers here, they now match. And if both rows of numbers match, the cable's actually good. And so, again, the top row is what it's supposed to be. The bottom row is what it actually is. So now, if I wanted to, I could take a look at what that might look like with one of the other remotes that you can get with the tester. You can order these separate if you like to. And having extra remotes is a very handy thing. So I'm going to take this 8 remote and plug it into the other end of that cable. And again, it gives me the same information, but now it says, hey, I see the 8th remote on the other end of that cable. And having the extra remotes can be very handy, especially on larger jobs, and you're trying to trace multiple cables at a time. And the problem with having only one remote is you only got one remote. So you're going to plug that remote into an outlet, go find that cable and do the test. Then you got to take this remote and move it to the next outlet. By having the extra remotes, I know that if I put a remote out in, say, the foyer in the front of the office, and I do a test on the cable, the meter comes back here and says pass, and it says it sees the 8th remote. Well, then I know that cable I just tested feeds that outlet in the foyer in the front of the office, so I can actually label my cable as I go. So very handy to have the extra remotes. So now let's take a look at a bad cable, okay? And I have several examples of some bad cables I have out here. And I'm going to plug the one end of the bad cable into the top of the tester. And I'm going to go ahead and plug the remote that comes with it in the other end of the tester. Okay? Now, the tester's showing us a little bit more. It's showing me that I'm seeing about a 7.5 foot piece of cable. It's seeing the first remote that comes with the tester. But it failed this time because it got the X mark here. And the 2 rows of numbers now, you'll see they're a little different. The top row is what it is supposed to be, but the bottom row says 2, 1, not 1, 2. And that indicates that we have a reversal in those pairs. And keep in mind, the reversals could be on either end of the cable. The tester does not know which end of the cable is miswired, but we do see a reversal in that pair. And again, the cable is about 7.5 feet long. So let's take a look at another cable. And another example of a bad one. And this time I'll plug the remote into one end of the bad cable, and again take the other end of the cable and plug it into the top of the tester. And now it's taking a look and give me some other indications. It's still seeing the first remote out there like we would expect it to do. It still sees a cable, in this case about 7.5 feet long, but now we have multiple errors. And again, the top row should be 1 through 8, but the bottom row you see says 2, 1, so there's that reversal we kind of saw on that first cable. You'll see the 3 and 6 are also reversed as well, so I've got a reversal in the green pair. It likes 4 and 5. 4 and 5 are the same top and bottom, so 4 and 5 is okay, so that's the blue pair. And over here, it sees an open in pins 7 and 8. Now, one nice feature of the TDR function is we can get an idea where that open might be in the cable, either on the closer to me or farther out. And so we know the overall cable length is somewhere around 7.5 feet long, but pushing the data button here, I can take the look at the different length of each of the individual pairs. And this is saying pin 1 and 2, pair 1 and 2, or pair, this pair here is around 7 foot long. That 36 is about 7 feet as well. And by the way, in a little short length of cable like this, you're probably not going to see a big differences in length here, because again, there probably isn't much of a difference in the length in that short piece of cable. 4 and 5 sees about 7.5 feet. But when I go over here and check for 7 and 8, it says it's more about 8 feet out toward the end of the cable. And that's at the very far end of the cable. So I know that open is actually at the farther end of the cable. And sure enough, back here at the plug that I put on this end of the cable, I actually put an open in the brown pair. So I know that if it said 2 feet, I would know that it's a little closer to me. So that's one nice feature, again, of having the TDR function in the tester. Now I'm going to take another length of cable that has no connector plugged into the other end of the cable at all, and I'm going to plug that other length of cable into the top of the tester. And it's showing me that it doesn't see a remote on the other end because everything's open, because the other end of the cable is completely open. But again, showing you some of the features of the TDR function of the tester. We can get you distances to opens or distances to a short. Now in this case, pins 1 and 7 or 8 are shorted by that little icon. That icon indicates that it's shorted, and it's about 24 foot out in the length of the cable. But if I hit the data button here, it's going to give me the overall length of the cable it sees. And so if you look at the longer distances in the cable, it sees more like about 104 feet of cable out there. Although in 7 and 8, it was showing me the short was about 24 feet out. And if I look at the distances out here on the opens on all these cables, it sees that 1 and 2 is about a pair. It's about 109 feet long. 3.6 is about 82.5 feet long, which seems a little short. 4 and 5 is more like that 104 or 5 feet that it thinks it is. And again, 7 and 8 is more by about 24. So I know the short in the cable is about 24 feet out. And I know 1 and 2 and 4 and 5 were somewhere close. 1 and 2 was pretty close to the 104 foot. We thought it was 109. 3.6 is at 82.5, and again 4 and 5 is at 104. So 4 and 5 and 1 and 2 are pretty long, but I noticed that 3 and 6 is a little short. And the reason 3 and 6 is a little short is because there should not be that big of a difference between the longest and the shortest pair, especially in a cable that's only about 100 foot length. So what I did was I actually put a cut in this cable about 20 feet back from the end of the cable. So this tester, again, is giving me the indication of distances to an open and distances to a short. So the opens we see are, one is the cut I made, and the other is the other two ends of the cable itself, and then there's the short there too. So very nice feature with the TDR function, and can be very useful when out there troubleshooting cables. So let's take a look at the next feature that the VDV Pro can do for you in data testing. A great feature of the VDV Pro is its ability to identify Ethernet devices on the other end of the cable, as well as active data networks, as well as power over Ethernet or PoE services. And to do that, we'll turn the tester on and make sure it's in the data setting, which it actually already is. And I'm going to plug it into this Ethernet switch I got plugged in down below it here. And when I plug it into that Ethernet switch, it's not powered, but the VDV Pro is seeing some shorts in the cabling, which indicates to it that it's actually plugged into an Ethernet device. And that little icon on the bottom indicates that, sure enough, we're plugged into an Ethernet device. Now, the switch is not powered, and I'm going to go ahead and power it up here. And when it comes on, it's going to tell us a few other things. And one thing it's indicating here is it's seeing either full or half duplex applications coming from the switch. And the switch has the capability to work at either 10 megabits per second, 100 megabits per second, or 1,000 megabits per second. So we're plugged into a gigabit Ethernet switch here. And it also shows the power over Ethernet that's available from the switch. And PoE is very common today. It stands for power over Ethernet, and IP cameras and voice over IP phones and all kinds of things can use PoE. And it's indicating that it's seeing about 51 volts of power, and pins 1 and 2 are the negative side, and 3, 6 are the positive side. And keep in mind that's a DC voltage that the switch is indicating here. And 51 volts is within the range of what you'd probably expect out of a PoE device. Now, you notice that the tester, if I push any of the other function keys, it will stay in this function. And the reason is because we've got something powered plugged into it. We don't want to necessarily damage the tester. But the tester does have one other nice feature to that, and that is called hub blinking. But one of the button I can still push is the wrench button or the tool button. And now it puts the tester into the hub blinking feature. And that feature is only available when you're plugged into a device like this. So it won't be available in any other function. You'll only find it here in the data section. Now, the hub blinking feature is not turned on because I've got the X mark showing it's not turned on. And through the function keys here, I can turn it on or off. And now it gives me a check mark saying, hey, the hub blinking feature is on. And technicians can use this because it's very, very helpful because I can plug the VDV Pro into a data jack in a room someplace, turn on the hub blinking feature to it, and help identify which port on the switch that particular device is plugged into. And so I'm on port number 1, and sure enough, port number 1 is flashing on the switch, indicating it sees the tester on the other end of the cable. So it's a very helpful feature when you're out there troubleshooting and dissecting wiring problems out there and trying to figure out where wires are actually running to back to a switch. So the hub blinking and the ability to sense active data networks is something you're not going to find in other wire mappers that are in this price range. So it's just a really great service and something the guys can actually really use in figuring and troubleshooting problems out in the field. To test a phone line with the VDV Pro, turn the tester on, and make sure you move over to the right mode, which is in this case phone. So I'm going to turn over here. Now we're in the phone mode, and nothing is plugged into the tester, so again, we get no type of reading. And as I showed you a minute ago, if I plug an active phone line to the top of the tester, it's going to indicate again that it sees a certain voltage and it sees a phone line. Now, besides testing for active phone services, we can test just a cable. And so, hey, I've got that little small patch cord, and I got one of the extra remotes here plugged into the end of it. If I plug that into the phone circuit, into the phone port, I should say, it's indicating that, hey, I see the 9th remote on the other end of the cable. The X indicates a bad cable because it sees an open in 1 and 6. And then it also gives me 2 rows of numbers here. The 2 rows of numbers should match. In this case, they do, except for 1 and 0, or 1 and 6. And 1 and 6, there's only 4 wires here, so that's showing an open. But you see 2s, the 3s, the 4s, the 5s, they all match up. And this is indicating that it's a straight-through wired cable, and since it's only about a 4-inch foot piece of cable, it's not even indicating the length to me here on this flat silver satin type of cable. But again, it does see that remote on the other end of the cable. So I can measure and test it for testing a cable, see if it's any good. Now, some phone cords are reverse wired, so the 2 rows would be exactly opposite of each other. So you might be aware of that if you're doing phone testing. But here I've gone ahead and plugged a second phone cord into the cable that I know is miswired, and the X indicates a bad cable because it sees an open in 1 and 6. It shows me it sees, in this case, the first remote on the other end of the cable, and with this bar across all 6 of them is indicating it sees about 41.5 feet. Now, the 2 rows of numbers are a little different now. The top row is what it's supposed to be, the bottom row is what it is. Again, the tester does not know which end of the cable's messed up, but it is on one end. But we see an open on pins 1 and 6 here because that pair is not there. We've only actually got 4 conductors terminated in this connector. And you'll see 3 and 4, and 4 and 5. 3s are the same, and 4s are the same. And you'll see that the 5 and 2 and the 2 and 5 are reversed. And so this is indicating a reversal because, again, the 2 rows do not match. Now, I could, if I wanted to, by looking at length again, by pushing the phone button, it's going to look at the length of pins 1 and 2, which is 0 feet because there's an open in it. 2, 5 is indicating about 42.5 feet, and 3 and 4 is indicating about 41.5 feet. So, again, the tester can be used to identify either a live analog signal, and it can also be used to test cabling for any miswires that are out there. So it's very helpful, again, when troubleshooting and working with phone circuits. To use the VDV Pro for testing coaxial cables, we'll very simply turn the tester on, and since I'm in the data mode, I'm going to push the coaxial icon until I get to the coaxial setting for the tester. Now, the tester does not measure signal strength. It's just going to check for opens and shorts and give you the length of a cable, as well as be able to ID a remote on the end of that cable so you know which end of that cable is connected to. So, again, length, ID a remote, and check for opens and shorts, but does not measure signal strength. So if I very simply want to use a remote that came with the tester, I can pull it out of it, and I very simply plug it right in the top of the tester. It's going to indicate that it sees, again, the first remote, and it gives me a check mark saying, hey, there's no opens and shorts, and it sees the shield and the center conductor, but there is no footage because there is really nothing plugged into the top of the tester. typically when you work with F connectors, we're going to plug a cable into the top of the tester. And when I do that, the tester automatically sees a cable. It sees an open in the cable because there's nothing connected to the other end of this cable. And it sees about an 8.5 foot long cable. Okay. Now, that length measurement, keep in mind, I could adjust that by going to the tool section and change that nominal velocity of propagation of a particular cable. In this case, we're set at 81%. But again, in this case, it's set at 81% and show me about 8.5 feet. Now, if I want to put something on the other end of the cable and put that remote on the other end, it will not plug into a standard connector like you see plugged into an outlet, but it would plug it right into an outlet. So if I have just the outlet in the room, the remote will go right on the end of that. So this male remote needs to see a female connection. So the tester does come with a number of these different adapters, and I can take this F connector adapter and refer to that as a F81 barrel. But anyway, plug that on the end of the piece of coax and then plug my remote in the top of the tester, and it sees the first remote out there. Again, it sees a good cable, and it sees a connection in the shield and the center conductor, and again, about 8.5 feet of cable. Okay, now that's basic F connectors. Okay, now say that you are dealing with a different type of coax, and it has something like an RCA connector on the end of it. Well, the tester has several different adapters we could convert from RCA to from F to RCA. So I'm going to take this RCA adapter and plug it in the top of the tester. Now plug that RCA cable into the top of the tester here, and then and since the remote will not plug into this RCA on the connector on this end, I'm going to take my RCA to F connector adapter, and now I can plug the remote into the other end of the cable. And again, in this case, we're seeing about, again, the first remote, and we're seeing about 12 feet of cable, and it sees the opens and shorts. And having the extra remotes are very handy because you can put them in multiple locations in a building and go down and find them one at a time, whereas if we have just the one remote, you end up having to move that every time you want to go take another test. And you have the ability to actually use some BNC to F connector adapters here too. So whether you work with BNC, RCA, or F connectors, the tester should be able to measure, again, basic opens and shorts in coaxial cables. To use the tone feature on the VDV Pro, you will not only need the VDV Pro, which can generate a tone or a signal on a cable that a probe, or an amplifier probe, I should say, can go out and find and trace it. And it's used for tracing wires. And I tell guys the more you do this, the better you're actually going to get at tracing cables. So you also will need an amplifier probe, and again, the tone generator inside of the VDV Pro. Now, it will put a tone out on a cable for 144 minutes. And it doesn't matter what kind of cable it is. We could do phone, we could do coax, or data networking cable. Matter of fact, the tester comes with an adapter from an RJ45 to some alligator clips that we could really, again, tone any type of cable we care to. And how far will it send a tone? It's really going to be dependent on the type of cabling you're dealing with. But I've tested 1,000-foot runs of category cable with really no problems, and hopefully you're not going longer than that. But it'll really vary on the type of cabling you're working with. Now, the tester will not let you go into the tone mode in two different functions. If I turn the tester on here, it's in the data mode, and it doesn't see a cable plugged into the top of the tester, so it's not in the tone mode. But if I happen to have a data cable plugged into the end of the cable, tester here, and it saw a voltage like PoE or something like that, the tester would not let you push the mode button and get into tone. Same thing if it was in a phone circuit and saw an active phone line, it would not let you go into the tone mode. Now, the other mode it will not let you use tone is that if you're in the tool functions here. So if I'm in the tool area here and the tester's asking me, since I'm in the data setting, hey, do you want to blink that hub? And I don't want to, but you notice if I push the button for generating a tone, it does not light up. So it will not let you actually generate a tone if it sees a voltage or is in this tool section, okay? Well, here we are. We're in the data section, and I can put a tone on a cable. Now, if I push the button, it's going to actually go into the last tone generation that it was providing on data. So it's going to save the mode you're using last time you used the tester. And it does that on all the coax or phone lines, too. So last time I had the tester in tone, it shows me it's putting a tone on a cable, is putting out the first of 4 analog tones that the tester can generate. And it can generate 4 digital tones, too, and which one you use is probably going to be dependent on your independent situation. But it is showing me that it's putting a tone on all 8 of the conductors. Now, I can put a tone down a cable that already has a remote on it, And if I plug that cable into the tester and actually try to find that tone, now you gotta understand something. This amplifier probe is picking up all the electrical noise around me. And obviously I'm in a pretty noisy electrical environment with all these lights around me, but I can find that tone on the other end of the cable with that remote plugged into it. Okay? Now, if I plug that longer length of cable we had earlier into the top of the tester, it's putting a tone down, and again, it's putting a tone down all 8 conductors like we want it to. And I don't have any remotes on the end of this on the end of this cable, but again, it's putting a tone down, and all the pairs sound about the same. And the reason is because it's putting a tone down all 8 of the different wires, so they're all making noise essentially. But by pushing the function key here for data, I can actually now put it down just pins 1 and 2. Now when I go back through that cable and I listen to those pairs, they're all about the same. But we are picking up a signal on the orange pair, which should be 1 and 2. Okay, and if I push the function key again, it can put down any of the pairs, or I could put it down just one of the 2 pairs. In this case, it's white, orange, and orange. And sure enough, orange is a little louder. Okay. Now, we can also change the type of signal or tone it's generating by pushing the tone button here again. Instead of using the first tone, which is this one, if I push the button, it's now gone into a little different sounding analog sound. And again, there are 4 analog sounds, and there are 4 digital, and we could listen to the digital as well. And so again, which one you use, I'm going to say really kind of depends on your particular situation you're into. But I could I could put a tone down each individual conductor if I wanted to, or again down all of them. So that's tone generation. And as I said earlier, tracing cables is a little bit of an art form. I've got a couple of videos up on my channel if you'd like to listen to some tips and tricks on how to use toners and probes. But that's how you use the basic tone generator in the VDV Pro. Whether you're using coax, phone wire, it's all about the same. Measuring length with the VDV Pro can be done using the built-in time domain reflectometer, or what we call a TDR. Now, a few things you should know about a TDR. They're only as good as what you tell them to do. And what I mean by that is all cables have a known what we call nominal velocity of propagation. And if we know that, we can set the TDR to that percent, which is basically the amount of time it takes the electrons to travel down a cable, which is some percentage of the speed of light. Now, you should also know that all cables you're measuring lengthwise should be uniform, and what we mean by and have what we call a uniform characteristic impedance. In other words, it's the same. You can change how the TDR measures length by, let's say, for instance, untwisting feet of a category cable, and you got some that are twisted. So we're changing again the characteristics and impedance of the cable. Anytime you deform the shape of a cable, you can do that. And for instance, coaxial cable, if I took a length of coaxial cable and I crushed it, I flattened it throughout the length of the cable, well, I'm changing the characteristic impedance of the cable, which changes this whole nominal velocity of propagation stuff. So we have to be aware of all that when working and using TDRs, which can give you distance to an open and distance to a short, or again, overall length of a cable. Now, we can set that NVP on the tester by simply turning the tester on, and I'm in the data setting here. So it's showing me about 100-foot length of cable, and I've got a cord plugged into the other end of the cable and really nothing on the other end of the cable, and the tester is showing me all opens. Now, the overall length we state in the specifications is about 1,500 feet or about 450 meters, and will it work longer than that? It might actually, but I could change the NVP by going to the tool button here and pushing it once. Now, the first thing it tells me is, hey, do you want to blink a hub? Because I'm in the data setting, and that's one of the functions in data, in which I don't. So I'm going to hit the button again, and it's going to ask me. Now, the second one is, hey, do you want to set this NVP on the particular cable you're working with? And you can see it's flashing 72% here. So for category cable, you'll find a lot of category wires are in that 72% range. But coax can range from 50 to and upwards of 80 something. It all really varies. You really have to go to the manufacturer of the cable to know the number. And on their specifications sheets, they should be able to give that to you. But I can adjust that by moving these arrow keys up and down. And you can see it does make a big difference in the length of the cable potential that I'm reading here. So again, knowing that MVP is kind of important. Now, if you do not know the MVP of the cable you're dealing with, you can take a known length of cable, and we recommend at least 50 feet, longer is better, and actually kind of adjust this NVP to match that known length of cable by moving, again, that NVP values up and down. Now, keep in mind, in category wires, the pairs are really twisted, and so cable is always marked on the outside of the cable by how long it is, and say it's 100 feet. But internally, that cable is much longer, so the electrical length is different than what we call the physical length in the cable. So in Category 5E cable, I'm going to say that's in the neighborhood of 5 or 6%, so the cable is actually more like 105 or 6% long, feet long, I should say. In Category 6 cable, it's going to be 10 or 12%, and in Cat 6A, it can even be more than that. So be aware of, again, knowing that NVP is kind of important. So if I push the tool button a couple more times, again, it's asked me how long I want the backlight to be on, and do I want feet or do I want meters here. And then it goes back and looks at that cable I got plugged into the top of the tester here, okay? Now, again, it's showing me about 100 feet overall length, and see that bar goes across the overall all 8 pins. It sees a short again in 7 and 8, but everything else is open. Now, this number you see here is actually the length of the middle pairs. And again, since all pairs are twisted differently, they're all going to be a different length. Now, pins 1 and 2 are about 105 feet long. 3 and 6 is about 80 feet long. 4 and 5 is what we should have seen before, about 100 feet. And then 7 and 8 is in that 23 feet. Now, we know there's a short in 7 and 8, and it's out about 23 feet out away from the TDR here, okay? Now, these other pairs, there was one that was kind of short. Overall length is 100, which is the same as 4 and 5. 1 and 2 was at 105, but you'll notice that 3 and 6 is about 80 feet. Now, the difference between what we think it is, about 100 feet long, and pin 3 and 6 was about 80 feet long, is more than the twisting would make up in the cabling. So I'm suspecting an open about 80 feet out from the TDR on that particular pair, okay? Now, one interesting thing about the TDR function on this, I've got this set in data at 72%, like I showed you a minute ago. Let's go, and even though I only have a piece of category wire plugged into the tester, not coax, these ports share the same bus. So if I push the coax button, it's going to read about 123 feet. If I push the phone button, it's showing more like about 90 feet long, and we are seeing about 100 there. So, and the reason that is because the tester allows you to set the NVP for each different type of cable, and it stores that. So anytime I do phone testing, it's set at like 60-something. Coax was set at like 58, and I had the data set at about 72. So one nice feature of the VDV is it will store that particular NVP you have for, and again, most coaxes, RG6 are going to have about the same NVP, so you'd like to be able to set that, okay? So let's move on to another function of the VDV. There are 24 cable identifiers that can be purchased separately with the VDV Pro, and they're great to have when trying to identify different outlets in a cable infrastructure in a building. So if you're back at the patch panel, the rack, and you're trying to figure out where all these different ports on the rack, what outlets they feed throughout the building, you can essentially take the identifiers and plug them into all the different outlets you have in the building, and then go back to that rack or patch panel and plug the top of the tester into each port individually on the rack, and then be able to find out if you seize a certain remote on the end of that particular cable. And that way, if we know that the 12th remote is out in the foyer in the front of the building, well, then we know that that port is the one that feeds that foyer. And to use it, very simply, you're going to turn the tester on. You've got to be in the data mode here. It won't work for you in any other type of mode. And I'm going to plug a cable into this tester here that's got a jack on the end of it here. Now, the tester is telling us it sees about a 22-foot cable, and it sees an open on the end of the cable where it's not able to do any type of a test because, again, there's nothing plugged into the end of the cable. And very simply, if I plug this remote into the jack, it now says that, I see the 12th identifier, and it's up the identifier icon, not the remote icon. And, again, about 22 foot in length. Now, it is not doing any sort of a test on the cable. It's just identifying the fact it sees that 12th remote. And you can still use the tone feature of the VDV Pro if you've got an identifier plugged into an outlet in a room as well, okay? Now, again, it doesn't work in any other kind of mode. If I push coax, if I push phone, it's not going to really show me anything as far as the identifier. Again, you got to be in the data mode in order to use it. And if I plugged a typical remote that comes with the tester. Again, it shows me the 9th remote, gives me the length as well, but again, I can test through the remotes. I can't test through the identifiers. But the identifiers are really great to have and can save you hours of time when trying to map out a cable infrastructure in a building. The VDV Pro is over voltage protected and can indicate certain voltages if it recognizes it. So if you turn the VDV Pro on, it's automatically going to go into a mode, and I'm going to go ahead and move it over into the phone mode here. And now it's looking for a phone line, and it's not indicating it sees anything because there's no voltage present. But if I plug an active phone line into the tester itself, the tester now is going to indicate that it sees some voltage, sees about 66 volts of an analog phone service, and it's on positive 3 and 4, and there's the positive negative of that DC voltage that it sees, and you'll see the tester is froze. Any other function will not work now, okay? Because it sees that voltage, it automatically won't let you do really anything else with the tester. Now, if I moved over and, as I showed you earlier, tried to do something with the data side and moved over to data and plugged a switch into the tester, as we showed you earlier with the PoE, it'll pop up and indicate that it sees a PoE voltage here, and then what pins it is available on. And again, if it saw an ISDN line, it would indicate it's seeing a digital phone line, and give the phone symbol with the 1s and 0s indicating that it sees a digital phone line. Now, if it sees any other type of voltage, and I'm going to take that RJ45 pluggy with those alligator clips and actually attach to a 9-volt battery to the tester. And there I've gone ahead and plugged a 9-volt battery into the tester. And as you can see, again, it's showing about 9 volts. It's on pins 1 and 2, and again, the positive and negative. And you'll hear the audible tone with the little lightning bolts on either side indicating, hey, there's kind of a strange voltage, kind of get me off that. And the tester will start indicating voltage if it sees about 2 volts and up, okay? And so if you hear that beeping noise, certainly get the tester off the voltage that it's seeing. And obviously, high voltage could be bad for a tester and really any type of tester. Now, some interesting things about the VDV, and things people will do, is say I happen to be in the data section here, and I went ahead and plugged a phone line into the data jack. Now, someone's going to do that. Well, the tester kind of goes into what we refer to as a safe mode and saying, you know what, I see a voltage, I kind of recognize the voltage, but you know what, you're not on the right port, man. And the tester's frozen now and is not going to let me do any of those other type of things, okay? And again, if I unplug that, it kind of comes out of the safe mode. And again, if I plug that Ethernet switch back into the tester, it'll indicate that it's, again, sees the switch and it sees the PoE voltages again, okay? Now, vice versa, if I happen to be in the phone mode, and I'm going to switch over here to phone, and I plugged, again, a computer into the top of the tester, and it's looking at that switch. The tester, again, since it's in phone, realizes it sees a voltage, and right there it did a very quick test on the cable going, that's something wrong, and it kind of goes off the line again. And every once in a while, it'll retest it going, hey, that's wrong, but it's not telling you the voltage or anything. It sees kind of a known voltage, but again, you have to be plugged into the wrong port. And again, if I disconnected that, comes out of safe mode, and if I plugged, again, a phone line in the top of the tester, it's now, again, going to indicate that it sees, the 66 volts like it did. And the same thing in coax. So say if I happen to be in coax, and I move over to the coax mode, and I plugged that computer again back into the top of the tester. It's interesting in this one, it's giving me the length of the patch cord. It's telling me it's shorted because the Ethernet switch on the other end of the cable has actually shorted it. And, since I have it in coax and I have the tester, something plugged into the data port, the shared bus is, in this particular point here for coax, is looking at pins 4 and 5 that are related to what's on the plug here. So it doesn't see the voltage because the voltage is being applied to 1 and 2 and 3 and 6. So it actually is doing the testing for me and can let me change the mode. But again, it sees something wrong. So it's not right. So again, make sure you're plugged into the right port when you're looking at the voltage and you have it on the right setting when you're doing it, and it eliminates some problems. And being able to identify a voltage that's present on the end of the cable is very handy when out there and troubleshooting either phone or data circuits. Well, that was a good look at the VDV Pro tester. I hope you find that was useful, and you can use that information to go out there and start tracing and testing all kinds of cables out there in those buildings. And again, folks, if you'd like to learn more, you can contact our customer service department, find a distributor nearby that stocks the VDV series of testers, or take a look at the website we have up on the family of VDV testers. Again, I'm Ron with Ideal Industries. I really appreciate you watching it, folks, and I'll see you on the next one.